Okay, Assalamualaikum and a very good evening to every one of you. So I'll continue with the video last part for introduction to probability. So basically I am planning to do this subtopic live in the class for next week for the period of 8 to 12 of March. But then for Monday cases only, for Monday I have an urgent method to do on Monday morning, so I couldn't make a live class for you guys, especially for Kuliah 3, but the rest will be live class. Okay, so this video is special for your kuliah 3 kan on Monday. Alright, so I'll continue here, but then I will share this to your kuliah only lah, this video part 3 classes punya ni. And then I'll put Q&A session in the Smart V3. So if you have any problem regarding on this chapter, you can directly comment there, or you can directly WhatsApp me. Okay, so this is the last subtopic for introduction in probability. So this is all about Bayes theorem. So Bayes theorem is related to the previous subtopic, the one with conditional probability. Okay, this one, yeah. Conditional probability P A given B, right? But then Bayes theorem will be used when your conditional probability is the reverse way. Okay, I'll show you later. Okay, so before that, we look through at the learning outcome first. Okay, at the end of the lesson, students should be able to understand and use Bayes theorem to solve probability problems. Alright. Okay. Remember the previous lecture. Sekejap ya. Okay, remember the previous lecture, the conditional probability of A given B is written as PA given B. So if you remember, this is given by. So basically this is the keyword for conditional probability. Second event happened with the condition that A already occurred. Okay, the event that has already occurred, and the event whose probability is to be determined. All right, so PA given B, this is the formula kan, PA given B is equals to PA intersect of B, and then the denominator will be the one at the back here. All right, so if you are given PB given A, okay, equals to 0.2, how we can find PA given B the reverse way? When the condition is reversed, Bayes theorem is used to solve such problems. So this is where Bayes theorem will be used. Okay. So we look at our tree diagram. Still remember, this is the form of our tree diagram. Okay, so total probability of event B is equals to PB. How we get this? Okay, so this is the first event kan? First event, this is the second event. So A and not A. So probability of A, probability of not A. And then this is probability B happen when probability of B if given the first event is A. So PB given A. So when you multiply this, PA and PB given A, you will get PB intersect of A kan. You will get this one kan. And then this one you will get PB intercept of A prime, right? So PB is given by PA multiplied with PB given A plus PA prime multiplied with PB given A prime. Okay, so B will be intersect with A plus with B intersect with A prime. That's why you will get the overall of B. Can imagine kan this one? So katalah your A and B like this kan, if let's say we define in a Venn diagram, so B intersect of A is this, all right, and then B intersect A prime, this area kan, B intersect A prime, so you will definitely get your B only, probability of B, all right. So outside of B will be the addition of PA intersect of B prime intersect of A plus with B prime intersect of A prime, right? Sama ya dia punya konsep. Okay, so the total probability theorem, the total probability of event B is equals to PB. So in general, okay, this one is the total kan tadi. If we look at this is the probability of B. Okay, so in general, if event A1, A2 up until AN are mutually exclusive, we still remember this, mutually exclusive, and exhaustive event, then the probability of B is given by PB equals to PA1 multiplied with PBA1, okay, plus PA2 multiplied with PBA2, okay, one term, A2 with A2, A3 with A3, and AN with AN. Okay, this is PB kalau ada banyak lah. Alright, so PA given B, the probability of A given B is equals to PA given B equals to PA intersect of B over PB. So when you bring this to the other side, you will get this. Okay, let's say we denote this as equation 1. Probability of B given A is given by PB equal intersect of A over PA, and then PA, this one you bring to the left hand side, you will get this as equation 2. If you realize here, PA intersect B is equals to PB intersect of A kan? PA intersect of B equals to PB intersect of A. So we can equal this equation 1 and equation 2. When you equal it, you will get PA intersect of B multiplied with PB equals to PB intersect of A multiplied with PA. This one kan, dia punya left hand side and left hand side dia orang will be, can be equal it. You can equal it together because we did not, we say that PA intersect of B equals to B intersect of A, commutative kan? So equation 1 and equation 2 equal to, you will get this. Alright, since PA intersect of B equals to PA intersect of B, so macam tadi, the previous slide, PB ini stay here kan? But then we bring it down. So this is what we call as Bayes theorem. Macam tadi, this one, PA given B, after I equal the equation, then PB, this PB I bring to the other side. So PB given A multiply PA over PB. So how, sama kan this formula? So how you can memorize this equation kan, this theorem? So PA given B, B, the probability of B at the denominator. So the first term will be the reverse of A given B. So you will get B given A and then followed by PA. Okay, very easy to remember kan, PB given A. So let's say our equation is PB given A. Okay, so we will get, alright, di bawah tu kita boleh tulis PA. So this one will be the opposite of B given A. So A given B multiply with PB. Can? Very easy. This one followed by here. Okay, so this is Bayes' theorem. Why they put I here? I here meaning that if you have more than two events, can? Just now you have only two events, A and B. But in this case, you can have many events, PA1, PA2, up until AN. Okay, so Bayes' theorem is useful when we have to reverse the condition in a problem. Okay, we look at the example. There are 12 balls and 8 green balls in a bucket. 2 balls are taken out in sequence without replacement. By using tree diagram, find the probability that the first ball is red. Okay, how we can get this tree diagram? I'll show you one by one. Yeah, wait a minute. Okay, I put new slide first. Okay, how you can sketch the tree diagram. Okay, you take out the information first, 12 red balls and 8 green balls. Okay, 12 red and 8 green, right? So 2 balls, you will take 2 balls, meaning that you will have 2 events are taken out in sequence without replacement. Without replacement, when you take out the first ball, the second probability will be affected. Okay, why I say affected? Because you didn't put the ball back. Right. So the first event, 2 balls are taken out in sequence, meaning that you take it out one by one, kan? So the first event, first draw, there will be 2 possible outcome, red or green, right? So the first ball you take out, the probability will be 12 over 20, kan? Number of S is 20 because 12 plus 8. So this is probability of R. And then probability of green will be equals to 8 over 20. Okay, this is first draw. Okay, second draw, since the condition is without replacement, so the probability will be different lah, kan? Red and green. So this is second draw. Okay, so this is the conditional probability, kan? So PR, R1 and G1 lah. This one is R2 and G2, R2 and G2. 2 means that the second draw. So PR2 given R1, kan? You take out our red color for the second row and take out, given that the first ball is red. So this will be, because you already take one ball out kan yang the red color, so the probability will be left 11 over 19. Okay, this one will be PG2 given R1. So this will become 8 over 19. This one, PR2 given G1 equals to 12 over 19. And this one, PG2 given G1 equals to 7 over 19. Kan? Macam gini ya, 12 over 19. Alright, very easy kan? Okay, so the question is, find the probability that the first ball is red. First ball, so first ball is red. You have 2 possible pairing. Okay, the first ball is red, second ball is green. The first ball is red, second ball is red as well. So from here, you will have 2 kan, R1 and G2. So we will consider yang inilah, this one and this one. Okay, so what is the probability of getting PR1? Okay, the first ball is red, so we will find PR1 sahaja kan, the event of R1 only. Okay, so it will be the addition of the first one, 11 over 19 times 12 over 20, plus with 8 over 19 times 12 over 20. The addition of these two will contribute to the probability that the first ball is red color. Okay, I think that one should be clear. 12 over 20. Right, the first ball is red. 12 over 20. Oh, okay. Sekejap ya. Find the probability the first ball is red. So what is the probability for this one? Calculate ini. It should be the same with this answer. Okay. This is overall kan. Dia bagi ni. This is overall. Right. So second question is the second one. The second one is red. If the first is red, R2 and R1. So this one lah. R2 given that R1. This one, R2 given that R1. So 11 over 19 direct from the tree diagram. Or use the formula of conditional probability. Boleh? Tidak masalah. Macam ni kan? Okay. And then second one is red if the first is green. Okay. Samalah direct from the tree diagram as well. Okay, dia bagi terus conditional probability. The second one is red. Second one is red. R2. Okay, sama kan yang konsep yang the first one tadi tu? R1 intersect. Because if the second one is red, it can be green R1, R2 or R1, R2. Salah, this one lah. And then the first one is red if the second is red. Okay, this is where we apply that Bayes theorem, because from your tree diagram, we have R2, G2, R2, G2, number 2 in front and given by event number 1 tu kan. So in this case, you want to find R1 given by R2. Okay, so by the reverse condition, then we will use Bayes theorem, because from your tree diagram, you have only conditional probability that the event number 2 first. We write the event number 2 first. Kita cuma ada yang macam begini sahaja kan, this one. Tadi dekat in our tree diagram, we only have R2 given R1, R2 given G2 given R1 tadi, mana tadi? This one. R2, R1, R2, G1. G2, R1. The first one is always 2, kan? But the last question just now, we want to find the reverse way. Okay? R1, PR1 given R2. So we will apply Bayes theorem. So R2 will be written di bawah. And then the first term will be the opposite of R1, R2. So it will be R2 given R1 multiply with probability of R1. Okay, so you just substitute the value and multiply, divide, then you get the answer 11 over 19. Alright, okay, let's look at the next example. I travel to work by route A or route B. The probability that I choose route A is 1 over 4. The probability that I am late for work if I go via route A is 2 over 3, and the corresponding probability if I go via route B is 1 over 3. Okay, this is also will apply tree diagram. So how you can choose your first event? How you choose your first event? Okay, you imagine yourself, which one happened first? You choose your route or you late for your work. Okay, you think it logically. Before, if you want to travel to work, first you have to choose your route, kan? So your route A or route B will be the first event. Okay, route A and route B. Alright, and then after you choose your route, then only the probability of you are getting late or not will be akan wujud. Alright, so you choose route A, then only there will be probability of late or you didn't late. Or if you choose route B, there will be a probability that you are late or didn't late. Didn't late, I put L apostrophe up there. Okay, so this is very easy. What is the probability that I am late for work on Monday? Okay, and then B, given that I am late for work, what is the probability that I went via route B? So this is the tree diagram. Okay, the first A and B, and this is the probability of 2 over 3. Why is it 2 over 3? It is given. So 2 over 3. So late, because it's saying here late is 2 over 3, meaning that did not late via route A will be 1 minus 2 over 3. So that's why the sini is 1 over 3. And then route B is 1 over 3. Did not late will be 2 over 3. Alright. Okay, so the question just now, what's the probability that I'm late for work on Monday? Late. Okay. You are late. You are late if you are choosing route A and you are late. Or you are choosing route B and you are late. So you have to consider these two lah. You add together. Okay, this one kan? This one. Alright, and then you get this 5 over 12. And how about the last one? Given that I am late for work, what is the probability that I went via route B? So this is to find probability of route B and you are late. Okay, route B and you are late. But from your tree diagram, you have PL given A. PL didn't late given A. And this one is PL B, PL prime and B. Okay, if you realize here, all are about L late or did not late at the first part of the conditional probability. But in this question, given that you are late for work, what is the probability that I went via route B? Okay, it's the reverse way. Okay, we are saying about late for work first, then they are asking you to choose the probability of you are choosing route B. So it is PB given L. So we will apply Bayes' theorem. Okay, so by using the formula, L is going down here, and then the first term will be the opposite of B given L, so it will be L given B, and then PB, and you just substitute the probability from your tree diagram, then you get the answer. Okay, 3 over 5. I think that one should be okay. Okay, I think this is the last example. Aisha, Siti, Muna pack biscuits in a factory. Okay, Aisha packs 55%, Siti 30%, and Muna 15% from the batch allocated to them. The probability that Aisha breaks some biscuit in a packet is 0.7. So in their factory, they are given they are given how many packs they should pack the biscuit. Okay, so before they break the biscuit, they are given how many biscuit for them. So maksudnya the first event will be the probability lah. How many probability? Let's say Aisha is A S M. So 55% will be 55% is 0.55. 30 is 0.30, 0.15. Altogether will be 100 kan? Okay. So this is the first event. The first event followed by the second event breaks some biscuit. Okay. So Aisha breaks some biscuit is 0.7. Can you see? Can see or not? Wait. I add one new slide here. Why cannot? Okay, this one kan Aisha, Siti, Muna. Aisha, Siti, Muna. So 0.55, 0.30, 0.15. Aisha break some biscuit is 0.7. And the respective probability for Siti and Muna 0.2 and 0.1. Okay, Siti 0.2, Muna 0.1. Okay, so they did not break the biscuit with B prime, so it's 0.3. This one 0.8. This one will be 0.9. Okay, you can see, yeah. So this is the probability of PB given A. This is PB prime given A. Okay, so if you can see here the conditional probability starting with an event of break the biscuit. So PB given S, PB prime given S, PB given M, PB prime given M. Okay, this one, right? Okay, so okay, sama lah. This is the tree diagram, right? So what is the probability that a pack with broken biscuit found by the checker was packed by Aisha? Okay, it is the reverse way, kan? Maksudnya the situation is they pack the biscuit and they break some biscuit, but they are asking you to find the probability because they're starting with the broken biscuit found by the checker. It's the reverse way. Okay, so the reverse way is you have to find PA given B. This one kan, PA dia gini, Aisyah, Siti, Muna, then break some biscuit. Okay, this is the arrangement kan, and then from this tree diagram we have the second event given the first event. They are the first event lah, but then the question is starting with the broken biscuit. Okay, starting with the broken biscuit, and it is broken by Aisha. It's the reverse way. So we want to find PA given B kan? PA given B, this one. So you just use the Bayes theorem and you substitute the value based on tree diagram, right? PB given A multiply with PA over PB. So how you get PB? PB is coming from here, kan? This one. Aisha break, Siti break, Muna break the biscuit. So additional of these three will give you P, break some biscuit. Okay, and then PA is 0.55 because this one kan, PA, and then PB given A is this. PB given A. Very easy. You just substitute the value and you get the answer. This is the probability. Yeah? So while calculating probability, let's say you get value greater than 1. So this is totally wrong because your probability of an event must be this one 0. From 0 to 1. Okay. So this is the conclusion. Conclusion is their formula in general. I think that's all. Okay, very easy one. So if you have any question regarding on this subtopic or the whole chapter, you just comment on the Q&A session in Smart V3. Okay, so there will be no online class on Monday just for your kuliah because I already planned it a few days ago, the moment when I give you the Google Meet link in the Smart V3, but then because of some matters, I'm very sorry. Okay, I couldn't make the class on Monday. But if you are free during maths class on Tuesday, Wednesday and Thursday, you can join the other kuliah together. Alright? Okay, I'll see you soon, very soon in the class. We are hoping to have face-to-face class very soon, hopefully. So everybody stay safe, jaga kesihatan. Okay, if you have any question, don't wait until final exam baru you want to ask the question. Okay, just WhatsApp me. I'll reply you faster or late, but still will reply your message. Okay, thank you very much everyone. Bye bye, see you.